Imagine a planet that looks as if it has been sliced in half by a giant knife. One half, a smooth, almost flat desert. The other, a chaotic landscape of mountains, craters, and frozen lava flows. This isn't science fiction. This is reality. And that planet is Mars. Since the 1970s, when Viking probes first sent back detailed images of the red planet, scientists noticed something strange. The northern hemisphere of Mars was astonishingly smooth, covered with only a few craters. The southern half, however, looked like an ancient battlefield. Millions of years of asteroid impacts leaving craters of every size. And more than that, the southern highlands stood 5 to 6 kilometers higher than the northern lowlands. This sharp contrast was given a name, the Martian dichotomy, and it became one of the greatest mysteries of the solar system. Nowhere else, not on the moon, not on Venus, not even on Mercury, do we see anything like it? The question that haunted scientists for over half a century was simple. Why is Mars split into two so differently? There were two main hypotheses. The first, external. Early in its history, Mars was struck by a colossal impact. An asteroid the size of our moon smashed into the northern hemisphere, stripping away the upper crust and leaving behind a vast lowland. This would explain the smooth surface and fewer craters in the north. The second, internal. Powerful flows of molten mantle pushed the southern half of the planet upward, creating an uneven relief. But for decades, both ideas remained speculation. There was never enough evidence to prove either one. Everything changed with NASA's InSight mission. In 2018, the lander touched down on Mars right at the border between highlands and lowlands. Its mission was unique, to listen to the trembling of the red planet. On Earth, we call them earthquakes. On Mars, Marsquakes. InSight detected hundreds of them, and when scientists studied how the waves traveled through the planet, they found a clue. The data showed that the cause of the Martian dichotomy lies deep within the planet. It's not just a surface scar left by an asteroid. It is a fundamental feature of Mars's inner structure. But the differences between north and south go further than just height. The Martian crust turned out to be much thicker in the south and far thinner in the north. Magnetic measurements revealed another surprise. Southern rocks are strongly magnetized. This means they formed long ago when Mars still had a global magnetic field. The northern plains, however, show no magnetism at all, hinting at a much younger age. And here we reach the most intriguing part. Many scientists suspect that the northern lowlands were once the floor of a massive ocean, an ocean that may have covered a third of the planet. The evidence? Possible shorelines, sediment deposits, and landscapes resembling river valleys and deltas. Skeptics argue the evidence isn't strong enough, that what looks like a shoreline may simply be random geological formations. But if that ocean really existed, it changes everything. Because where there is liquid water, there may also be life. The Martian dichotomy is more than a geological oddity. It is a key to understanding whether the red planet was ever habitable. Did the northern lowlands preserve traces of ancient microbes? Did Mars once have an ocean like Earth's seas? We still don't know the final answer. But one thing is clear. Mars is far more complex than we imagined, and its story is far from fully told. So next time you look up at the blood-red disk of Mars in the night sky, remember, you're looking at a world with two faces. The ancient mountains and craters of the south, and the mysterious plains of the north. And somewhere in between, the truth about whether we are alone in the universe. Don't forget to subscribe to Hypothetica for more cosmic stories. And give this video a like if you're curious to see what other secrets the red planet is still hiding.